All right. Welcome to the July 1st Arborist call. We'll get going today. Same agenda as always. Quick welcome and meeting intro. We'll go through some research and implementation status updates. If we have any of those are optional. If there's anything specific the teams want to talk about with regard to the node implementations, either Zcashd or Zcashd, we bring that up in there. And then we have a general discussion section, which is where we spend the bulk of the time. Today, we were going to go over NU5, kind of just a general status, audit update, timeline update, and then anything else that time allows to discuss, and then just kind of a wrap up open announcement section. For those that might not be familiar with Arborist calls, we have these every 2 weeks. And it's where we talk about all things protocol. So protocol developers and contributors and those interested in that development get together to talk about upgrades, R&D efforts, design, implementation, and just in general, all things protocol. Anybody can participate on, of course, any team, any protocol team, or just any member of the public interested in protocol development. If there's something you want to present, you're welcome to do that. Or if you just want to suggest a topic for the teams to talk about and discuss on a call, you can just suggest that to me. Just send it to me, Stephen@electriccoin.co, and we will get it slotted in. We've moved to a 2-week schedule sometime back, which has worked out really good for us. So we usually have a lot more flexibility in working things into the discussion. So just moving on to the implementation status updates, anything from Zcashd that the team would like to point out today?
As we've said the last few times, we continue to make progress on implementing NU5 and all of the consensus rules that are active as of Canopy. One thing that's probably worth noting, because I know that it's come up before on this call, Zebra used to just connect to as many peers as possible, as fast as possible. We've done some things to limit the reconnection rate there. We're also gossiping some unreachable addresses, and we've done that, done a fix to make sure that we're not doing that. So those fixes will be in our next release, alpha release, which should be out next week sometime. There's still some things that we need to fix. We're working on limiting the absolute number of connections that we have as well, and that should be out in a few weeks' time. There's nothing in particular in terms of the node status update. Otherwise, we're keeping up with the spec changes that have come out recently, but there have been a lot of them. So I guess it's fortunate for us that we don't have a full client implementation. Otherwise, there would have been a bit of rework from that. And we're still waiting on the Orchard circuit so that we can do that part of the proof. And we'd be interested to know when some of the when releases for some of our dependencies will be tagged. We're not strictly depending on those, but it just makes tracking those releases a bit easier if we have tagged release numbers rather than updating Git commits all the time. And that's about it from us.
All right, very good. So the Zcashd update, normally, like, let's just call it mid network upgrade cycle, we would kind of highlight some things that we put into the most recent release. But today, obviously, our focus is currently on NU5. So we'll just, instead of having a specific Zcashd update, which would largely be NU5, we'll just move to an NU5 discussion. The feature set, I always kind of start with that. So everyone has a level set of the items going into NU5, the zips. The ones in bold are the deltas from the last Arborist call. And these are, the ones that are in bold are existing zips that were updated to reflect, in some cases, Orchard addresses in the case of Orchard support in the case of shielded Coinbase. You could also use sapling, of course, so we updated that zip.
There's a minor error on the slide. It should be zip 213 shielded Coinbase.
Oh, is it 213? You're exactly right. Okay. Yes, I copied that down.
213
It
is
was my fault.
something else. It's the transaction fee change.
Right. That is correct. Yes. So anyway, I'm going to fix that right now. That way I don't proliferate this error around. But at any rate, Strad, you want to provide just any kind of quick update on the ones that we've added here in bold?
Yeah. So all of these are things that that we knew had to happen because it was effectively part of the zip 224 changes for Orchard. But the direction that the zips have been heading in for a little while now is trying to move towards making some of the more long-standing ones moving them more towards being living documents. So that we have a single place to go to for like that area of the protocol. So we'll have to have some discussion about how to better manage that going forward. But in any case, the deltas on this are effectively for 212 and 213. Well, 212 is trivial. It's just saying Orchard, we do OXO2, done. It's because the note plaintext format for sapling and orchard is identical, and we're preserving the change. The changes that were made in 212 are being preserved in 213. So for simplicity internally, the format is the same, and it is in the same version space of plaintexts, but effectively the OXO1 case will just never exist for Orchard.
Yeah, there is some small differences in how you derive the fields of the note in Orchard, but it's pretty straightforward.
Yeah. And in the shielded Coinbase case, it's, as you would imagine, allowing Orchard outputs to be present in a Coinbase.
These changes were already present in the spec, so it's basically just updating the zips to be consistent with the spec and not contradict them.
Yeah,
that's all it is. The change to zip 203, that was a new consensus rule, which was to fix a problem with transaction ID uniqueness.
Yeah, kudos to Tail for spotting that one.
Yeah.
So yeah, the quick summary of that is that we activated BIP 34 from launch, which was effectively ensuring that Coinbase transactions committed to the block height they were going to be mined in, and that ensured there wasn't an easy way to duplicate TXIDs, which Bitcoin, it was possible before that BIP activated. Because we've had it activated from launch, you've effectively been able to assume that TXIDs would be unique, because to break that, the only way to do so was find a collision in SHA-256D. But with ZIP 244, the TXIDs no longer commit to these script SIGs, and that it was where the height was being inserted. So it enabled the TXIDs to become duplicatable again. But fortunately, ZIP 203 put an explicit field in transactions from overwinter, which is the last height at which a transaction is valid for mining. So we can just set that to the block height. So that's the change that's made to ZIP 203. Also means that we have a much easier place to grab block heights from now, rather than having to extract them from scripts.
Yeah, right. And with reference to that, note that this change is made also for version 4 transactions, not just for version 5. So that's needed if we want to use it to simplify getting block height.
Yeah, it makes for much simpler introduction of those rules, because this is then just a block level rule rather than a V5 transaction rule.
Question, Deirdre?
No, I'm just, I have to go reread that zip, but.
Okay. All right. Hey, a quick program update or agenda update. I coordinated with the Ziggurat team. It actually right before the last Arborist call to present. So we actually have, and I may pronounce the name wrong, I apologize for that in advance. Mirko from Equilibrium is going to pronounce Ziggurat. So we should have plenty of time. We'll get through the NU5 update pretty quickly here. And then, yeah, we're we're super excited about that. That's been already very valuable project for us. So
Yes.
yeah, so we're really excited about that. So I apologize for not having that in the agenda up front. I'm a little scatterbrained these days, I think. But at any rate, okay, so any other questions about any of the zips or anything before we move to the next slide? I'll do a quick audit update. All right, so as everyone knows, we're working with Kedit and NCC on the audits. Items in bold are a bit of an update on timeline. We've kind of shifted the Kedit audit a bit so that they have longer to look at the circuit, essentially. So our interim findings will be July 8th, and then the final report will be July 15th out of Kedit. NCC is also making progress as well. The original project readout was going to be July 2nd, which is tomorrow, but we didn't get that scheduled. So it'll be sometime after the holiday week, so or sometime during next week. Tayor, you had your raise hand.
Yeah, there have been a lot of spec changes over the past week or two. Have those been sent to the auditors, and how are the audits on them going? Or how's the timeline going to need to be adjusted for that?
So a number of those changes are us responding to things that have come up during the audits.
Yeah.
So I don't know the specific distribution of in DARE in terms of how we've split them up in there, but a number of things that have gone into those changes are just reacting on the fly to things as the auditors pick them up.
Yeah, and I'm just looking at the most recent changes today. So, I mean, 5 of them are just fixes that are either independent of NU5 or just trivial typos and stuff. Then there's the change that we made to the checking of note Merkle trees. So for performance reasons, we no longer check that each intermediate root is not bottom. And so that, like Strad says, that was a response to the previous way that we'd done this was a response to a finding of NCC. And we found that the way we'd proposed to do that was creating a significant performance impact. And so we had to change the way we did it. And then there's one rule, which is basically just something we'd missed, that there's a case where there are orchard actions, but both the enable spends and enable outputs are disabled, and that case is useless, and we decided to prohibit it.
Yeah, it doesn't really matter if it existed or not, but it's just eliminating useless data from the being able to be added to the chain.
Yeah, so there are only, although the latest change to the spec has 1, 2, 3, 4, 5, 6, 7, 8, 9 entries of things that are changed, so there are really only 2 significant consensus changes.
Yeah.
Okay, Walter had a question. Are Kedit and NCC auditing different things or the same? In some cases, there's some overlap, of course, but for the most part, they're focused on different things. It was before my time, but I'm pretty sure Kedit did some work for sapling, so they were pretty familiar with the sapling circuit. So since we tried to structure Orchard in a way that was as similar as possible to sapling, we kind of tapped Kedit to come in and do the kind of a focus on Orchard and the Orchard circuit. NCC is looking at, if you go back to that list of zips, the other implementations like transaction malleability, transaction version 5 format, et cetera. NCC is looking a little broader at the zip implementations themselves.
Yeah.
Okay. So, all right. So anyway, that's kind of the status.
I'm hoping, by the way, that the changes to spec will settle down at this point. I mean, touch wood, and I hope I'm not proven wrong, but I think I'm pretty happy with the spec at the moment, and I think there will be very few, if any, additional changes for NU5.
Yeah, we've had as the schedule shows, like a few different like status updates, and this is, by the way, this schedule was the implementation audit side of the audits that we did, a specification audit, the audits earlier, but we've already had kind of a couple of interim meetings, so we've gotten a lot of the kind of the more obvious things we need to adjust in the spec out of the way. So hopefully, as Dara said, we won't have really anything else, or if so, it'll just be very small.
I mean, the main reason I think that is that we've pretty much already finished the almost all of the changes to the consensus rules, and it's when you're implementing that you find inconsistencies and things that actually can't be implemented efficiently.
Yeah. I think the only thing the only two things that are not implemented at the moment for Zcashd are the change, propagating the change for Merkle CRH, which is implemented in a PR, but we haven't merged that yet, and the circuit. Everything else is merged into Zcashd in terms of consensus rules.
Is that mapping bottom to zeros?
Yes, that piece. So we have the spec PR over in zips.c.cache, the Zcash repo, and we have the change to the orchard crate. There's a PR open for that, and once we've reviewed those, they'll get merged and then migrated over to Zcashd.
Okay.
Yeah.
So is there a likely date you'll be tagging some of your releases for some of your Rust dependencies, or does that all wait until Zcashd is ready and the circuit is done?
Yeah, we obviously can't tag the orchard crate before the circuit is done, but we've been tagging smaller releases as we go. So Pasta Curves is tagged, the incremental Merkle tree crate is tagged. Halo 2, we're hoping to have that tagged really soon, and well, I don't know if Sean's here, but yeah, we're definitely within the next week, and hopefully in the next few days we'll see how that goes. And Libra Zcash, we can't tag that obviously until we have the orchard stuff done because of the interdependency there. But we're aiming to have everything tagged for use in Zcashd. There's a slight hitch to do with the Funty problems, because some of our crates over in the Zcash star crates depend on the nom crate, and that hasn't yet been updated past the Funty problems. So we may not be able to tag a couple of crates on the periphery there. But things like the Zcash note encryption crate will get tagged and so on. And so I expect, yeah, in fact, that one could be tagged now, for instance. We haven't really touched it in a couple of weeks. We just tend to tag all those repos at the same time. So.
All right. Yeah, looking at the overall timeline, it's kind of what I had put up the last call. We are right in the middle of our audits, and subject to change, but we're looking for a testnet activation second half of July, most likely toward the end of July. But we'll be in a much better position, obviously 2 weeks from today on the Arborist call to kind of go over where we think we're at and look at potential options for when we could set that height. But again, all dependent on the audits and the progress we can make between now and then. All right, so at this point, I think I'll stop presenting and we'll move on to Mirko from Ziggurat, if you're ready.
Hey, sure.
How do you pronounce your name? I'm so sorry if I got that wrong, by the way.
No stress. I'm so used to people butchering it left, right, and center. But you did perfectly fine, thanks. So
okay, great.
Yeah, good. But yeah.
All right, very good. All right, well, thank you so much for joining us today. We've already gotten a lot of value out of the Ziggurat framework, so I'm interested in learning more.
Yeah, okay, so sharing. Right, I presume you guys can all see that. I no longer can.
Yes, we do.
Okay, okay, great. Yeah, so I'm just going to give a short overview, I guess, of what Zcashd is for the people that aren't familiar. And then just briefly go through sort of the high level overview of things, give a couple of code examples, some highlights of things we have found, some things we found difficult to do, and then things that we might be, well, things that might be of interest to do in the future. Yeah, so for the people that don't know what Zcashd is, the idea was, or the concept was, to have a black box testing suite that targets the network protocol layer of Zcash nodes. And it should be capable of testing both Zcashd and Zebra nodes and potentially any other future node implementations that get created, I suppose. Yeah, it's fully funded by ZOMG. Yeah, and then when we first started the project, we thought, well, we're going to split the tests into sort of three main areas. One is conformance. That's pretty much just sort of basic unit tests equivalent to it. So does a node handshake correctly? Does it respond correctly to a ping and a pong and that kind of thing? So you're not testing, yeah, you're just testing, does it do the correct thing? Then performance, and that's pretty much stress testing it, putting it through a lot of, well, spinning up a lot of connections, seeing if it buckles, seeing if it slows down. Basically, is it well behaved when you throw a whole bunch of stuff at it? And the final one was resistance, and that's sort of akin to fuzz testing, or you throw nasty things at it and see that things still, hopefully it rejects it, or handles the message as it should, even though it's malformed or nasty. Oh, the project status, I think we're currently wrapping up milestone 3, I think, and that should be handed over soonish. This is sort of the outline of the original grant. What happened with 2B was that when we got to this point, the idea was to have some fancy graphs and that kind of thing. But once we got to this point, we found that most of our output wasn't very visual friendly. And we decided to roll this, sort of spend more time actually doing better testing, and yeah. All right, so yeah, we developed this in Rust and used the Tokyo async runtime. Yeah, it worked really well, I've got to say. And like I said earlier, we target both Zcashd and Zebra implementations. Yeah. And the sort of typical test case looks more or less like this. We have a user-defined configuration file. It's very simple. It's pretty much just to tell us, listen, what kind of node are we targeting? So in this case, it's a Zcashd node. Okay, where's the Zcash repo that you want us to test against? And then start command. So it generally looks like this, and then just some extra options that you might want to pass through to Zcashd. Technically, we could sort of abstract this away, but we found this very useful to try out certain commands and having certain initial conditions set. And the Zebra config looks very similar. For example, here it's sometimes nice to, well, if I, for example, want to compile with nightly or something like that. So this would compile and run your Zebra. So once we've written the configuration, we spin up a node. Maybe important to note here that we actually, so I think both of your nodes take a configuration file themselves. So we actually generate that configuration file based on the requirements for that specific test case, plus whatever options you defined in the previous case, in the previous configuration file. We then execute the test case and shut down the node again. We've abstracted 1, 2, and 4 behind our own node type. So it's the one that is responsible for starting the node, configuring it, and shutting it down again. And 3 is sort of where the actual interesting stuff happens, I would say, and most of the network communication and that kind of thing is handled by our own implementation of something called synthetic node. It's basically a very, very, very dumbed down version of your guys' node. Pretty much just capable of handshaking.
Similar to the mini node in the Python tests, I guess.
Yes. Yeah,
question.
Yes.
Does that use any dependencies from either of our teams, or is it? No. Okay. Nice.
There's no direct linkage between the crates or the repositories at all.
Nice.
There may or may not be some inspiration from the source code, I guess, but but otherwise no.
Yeah.
But having looked through the Zebra dependencies, we do end up using some of the same things, I suppose, in that sense. But that makes sense.
Right. Upstream dependencies.
Yeah. No.
That
So
are not.
Yeah.
Okay.
Yeah, and the synthetic node is, you can basically configure it to perform handshaking or not perform handshaking, to respond and filter out some of the messages, basically to just automate sort of the normal node execution things so that we can actually focus on the more important things on the test. So as an example, some code, here's sort of the very first test in our suite. And it's basically just checking, does the node behave well just when you spin it up and try and initiate a connection to it and just handshake. So this here is your node that we're starting. You can see here we've augmented it with this, well, I say augmented, but we've got a couple of actions that we can start a node with. And our problem was basically we can start the node as a separate process, but we never know when your node is actually ready to communicate, because it obviously has a startup time. So one of the things we implemented was this wait for connection, which inside of the start method, we actually spin up our own node and it waits for your node to communicate to us. And at that point, we know your node is ready then for further communication. There are other actions here as well. The only other one, well, there's two other actions. One is none, and the other one is seed with sort of data. And that what we do there is we wait for the node to start up and actually seed it with some of the initial testnet blocks, so that we can test peering and actual block communication and that kind of thing. We then create a synthetic node. So this is our fake node or fake peer. And we can, one of the things we can configure it with is its handshake capabilities. So in this case, we're configuring it to perform the full handshake. So send a version, receive a version, send a verac, receive verac. We then inform our node, instruct our node to connect to your node. And once that's completed, we then just check, listen, is our node still connected to your node at the end of this? If this connection failed, and this connection includes this handshake that we configured here. So if any of this failed, this would fail and the test would fail. And then we just shut down the nodes again. So most tests look like this. Whenever your node is the one that whenever we connect to your nodes, the tests look a lot simpler. When it's the other way around, it gets a little bit more complicated because we have to be ready for your node to communicate to us before we can actually start your node. So that, as something a little bit more complicated example, what we're wanting to do here is check that the node ignores, well, instead of sending verac, we're sending other random messages, valid messages, but they shouldn't be, your node should ignore them, basically. So we'd be, for example, we'd send version, you'd send version, and then we'd send, I don't know, ping or get data, and yeah, and expect you to ignore that.
Strad, you had a question? Your hand was up.
Yeah, just on the previous one, I note, so you do the test with an assertion. So you have a graceful shutdown, which obviously works if the assertion passes. But are you doing anything if the assertion fails, or is it just tearing down everything in line?
So these do actually have these do have these exact same methods implemented on drop as well. There are some things that are nice to have in this kind of way, though. For example, the node stop here also includes a check to see if your process crashed, which is not always. So what sometimes happens is that this will pass. Well, I say sometimes, but it's technically possible for this to pass, but the node to be crashed, depending on timing.
Right.
So
Okay.
we can technically remove this, and because this happens on drop anyway. But if this panics, and then this also panics because the node was crashed for whatever reason, then we don't see that. It doesn't come through very clearly always, basically. So it's nice to have it despite the fact.
Yeah, I was curious there because I know in our Python RPC tests, assertions, of course, in Python aren't really panics. They're sort of they throw exceptions that you can catch, and I think the handler always captures all of those. So I was curious if you were doing anything with like catch panic or anything.
No, we're not doing anything special.
Okay.
They are, we're just using the basic Rust test runner currently.
I guess you only want to report the case where the node has crashed as a failure if the rest of the test passed, because otherwise it's spurious. It's just because of the previous failure.
Yeah, honestly, if the node crashed like hard crash, that would be of interest too.
Yeah.
But it turns out it's quite difficult to reliably catch these things in action from another process. Yeah, so we try to cover as many bases as we could, but it's still theoretically possible for things to go very pear-shaped, and yeah. But hopefully the logs will show that. Yeah. Okay, so what we're doing here is we're once again building instead of starting with your node, we're starting with our node, and we're building, and the handshake that we're enabling in this case is only the version should get exchanged. So we're not automatically doing the VERAC part of it. And this next line here with all auto reply, this is sort of the built-in filter in this node. Basically, for a bunch of message types, it will automatically respond with some other default message. So if you send a ping, we'll respond with pong. If you send get data, we'll respond with some other empty set of data, or something that's valid for that request. This just helps us get around things like, we expect you to send something and then you send a ping, which is completely legal but annoying in a test. Then we're building n of these, and we're basically building a synthetic node for each one of these test messages that we just generate up here. We then, because in this specific test, we're actually letting you connect to us. In other words, we're setting all of these, we want to send all of these fake nodes as initial peers of your node. So when we start up your node, it's going to start up and immediately try and connect to us, which means that we need to be ready for this before we actually start you up, which means our node processes need to be happening in some other parallel fashion, in this case, we're spinning it up as a future. So one future for every node. And the function that's running is this thing called simulate peer. We'll look at that at the next slide. We then start your node and set the initial peers to the list of, well, basically we give your node our node's addresses to start with. And then we wait for the simulate peer to finish for each of our nodes, and then we stop. The simulate peer function is pretty much just this. Because we're already connected, we're going to expect now to receive a VERAC from you. Because in the previous set, we told it, listen, you need to perform this version exchange already. So by the time it gets connected to, it already done the whole version to and fro, but it hasn't done the VERAC to and fro yet. So we receive your version here, your VERAC here, and then we send something that isn't the VERAC. It's one of these random test messages that we generated in the previous step. We expect you to ignore this. We then send Verac to complete the handshake. And it kind of gets a little annoying here because you can't really test if a node ignored something. Well, you can, I suppose, by just waiting for forever, but that's not really, it's not a very strong test. So what we do is we actually initiate a ping pong sort of test after that. So we send a ping and expect it to pong back within some timeout. And
Oh, I
if
see.
you
So
ignore
that's-
this should work. Yeah.
And that works because the queue of messages between the nodes is ordered. So
yes, if that wasn't the case, then we'd be doing a lot of guesswork.
Before that. Okay.
Yeah.
Yep.
Yeah. It would be significantly harder to test these nodes if the order of response was arbitrary.
Yeah, but if that were the case, then it would pretty much be necessary for any kind of request response to have like tagged IDs and things in the protocol, which it doesn't have.
Yes.
Yeah.
Yeah, I mean,
basically a 1-to-1 FIFO ordering protocol.
Yeah, so it kind of comes up when you guys have, it comes into play when you guys have to ignore sort of these weird messages because you may have been connected and then disconnected and reconnected and there's still things coming through, I think.
Yeah.
So that, yeah, in general, this works nicely just because things have to be ordered. Yeah, so this is a sort of the moderate complexity example. I'm not going to go through it. Are there any other questions about this? This is sort of the last bit of code that I'm going to be showing.
Looks very nice.
It does. Looks very nice.
Yeah, it looks like very clean code. You can see how you would write more complicated examples.
Okay, great. Yeah, and then just a brief mention of what we have found. So there've been, I think, mainly in Zebra that we've had a lot of issues that they've been publicly opened. So there's, as far as I could tell, there've been 7 issues, 2 closed, of which 2 have been closed. So there's still 5 sitting there, and 5 closed PRs. There's one issue that we found. Oh, there's one open issue in Zcashd, and then there's a couple more possible bugs / maybe that are still under investigation, I think, as far as I understand.
That's
yeah,
correct.
Yeah, okay. So yeah, I singled out this zebra crash here caused by the timestamp parsing. It's been fixed, so that's why I'm mentioning it. But what's also interesting is when we first started, we had instead of having this synthetic node that sort of handles all these things internally, we had just we basically just did the network calls manually. So you'd see a bunch of network sends and receives in a row. It looked a lot less clean. And then when we moved to this sort of implementation of the synthetic node, we ran smack bang into this exact same crash. Yeah, and then I guess other things are just inconsistencies between Zebra and Zcash with ways in which you handle certain messages or certain scenarios. Also weird behavior or different behavior when you have very few nodes versus when you have a fully established network. And sometimes nodes are very, very eager to communicate, sort of at the detriment of themselves in some sense. Yes, I think we've made good. I think we found some very solid things actually.
I agree.
Interesting.
Yeah, thank you.
Yeah, and then just to mention what we struggled with. So obviously, I mean, a lot of these things we knew going in, so these aren't surprises. It's more just, I think, worth mentioning again. So the fact that Zebra is still somewhat behind in some of the features makes testing difficult. Just from the point of view that you try something and you expect a certain result, but you're not sure if what we are expecting is actually the correct thing. For example, when we first started, we didn't expect you to ignore certain messages. We expected you to just terminate the connection. And for example, Zebra actually does that sometimes. So we thought, hey, great, we're doing this the right way. But then when we tested against Zcashd, that wasn't always the case. It made it difficult to decide which behavior was the correct behavior. Yeah, and then that sort of tied into that, kind of having a formal network protocol, sort of where you can say, listen, if this happens, then we should do this. And having that written down obviously makes testing a bit easier too, just because we can then say, okay, this is what should happen, and we can just fail a test based on that. And the other thing that we found was, because we did, in order to sort of understand what the node was doing and maybe why our test expectations were incorrect, because that's obviously a very possible kind of thing, right? Like where we decide something makes sense, but then when we get to the actual test, none of the nodes actually behave in that way, and we don't understand why. So we investigate the logs and investigate the code to try and figure out if we're being stupid, which is often the case. But something like structured logging would make something like that a lot easier, especially if you have a lot of nodes. Figuring out why one of those connections is behaving strangely is extremely difficult when you're trying to dig through the logs. Yeah.
Yeah,
Have
we've
you,
seen that in RPC tests. It's very difficult to debug because you don't even initially know which node went wrong.
Yeah.
Have you looked at tracing? We're implementing that in Zebra, and it can make some of this structured logging helpful, especially in an async context.
Yeah, the Zebra logs were definitely a lot better once, because I think, okay, maybe I'm misremembering now, but somewhere about a couple of months ago, I think the logs started becoming a lot more, there's a lot more nuance to the logs suddenly, which was great.
Yeah, and on the Zcash side, yeah, we migrated, I think it was mid last year, the entire logging system to tracing, including on the C++ side. But obviously, there's a lot of logging that is inherited from Bitcoin, and so like we've adapted it where it makes sense, and we've added a couple of like tracing spans and things to like network peers where we can. So in theory, you can like add a bit of logging in that sense, but there's definitely more that we could do to expand that.
There was definitely enough. Yeah.
Yeah.
Sorry, I have a question about Zcashd. So is there a way I can see tracing spans in the log? Like, is there an option yet? Or
yes, you see them by default. So the reason you don't see many of them is because there aren't many implemented.
Okay.
Because we weren't implementing the network stack from scratch with tracing in place like Zebra has, we don't have all the instrumentation all through, but the ability to add it is there. So for instance, at the moment, every node sets itself up with a tracing span per peer. So when you're in the context of a node, you can log it. However, the default logging that Zcashd doesn't include any network logging whatsoever. So that's why you don't normally see it. We didn't really disturb the main logout. But if you run with debug equals net, you will start to see tracing spans involved based on peers. And then you can use the set log filter RPC to actually put in tracing filters where you can actually use more of the tracing logic than is possible to configure just with the standard Zcashd debug equals foo configs.
Yeah, for Zebra, as Trad was saying, we've always had structured logging. And it's just that some of the details will be at a debug or trace level. Yeah. So it's all in there, and it should all be available. The one thing that occasionally happens is that we make code changes and we forget to propagate the spans. And so suddenly they'll just disappear from an entire tree of async calls or function calls. Usually span propagation is automatic, but there's some cases around async code where it's easy just to drop them. So that's the only thing there. And if you do find instances of those, please let us know, because we'll probably just treat it as a logging bug.
Oh, that's good to know. No, the Zebra ones were definitely a lot more, what's the word, covered.
Oh, well,
Yeah.
we needed that to work out what was going on in our code when something went wrong.
Now I can believe that. Yeah. Lastly, just things that things that we were thinking about for future work. So currently we're using the just default cargo test runner, and because we're spinning up a node for every sort of test case, and spinning up a node is quite heavy, right? It takes a few seconds. It would be great to be able to say, listen, these tests all they don't change the state of the node, so we can run them all against the same node and sort of bundle them all together. So we've already bundled quite a lot of these things together where they made sense. So it's the same test, just with different message types, for example. But just having a sort of custom test runner would help us, would let us sort of exercise better setup, tear down features, and basically the test would just run faster because we'd have to spend less time spinning up nodes and destroying them again.
Just a question there. How do you make sure that the tests don't change the state of the node in terms of the network stack or the connection state?
As in during a single test, or?
Well, you said you could bundle tests together because they don't change the state of the node. How can you be sure of that?
Certainty is probably low. Well, not low. We can't be certain, but we would say, listen, these tests don't rely on, we assume these tests don't rely on its state in any way. For example, just testing, does it respond well to a single node?
And what you could actually even do is that custom harness could have, the ability when you run the test to specify a flag that means run these all in independent nodes anyway. So your daily driver could run them bundled, and then you might just have a test, a variant of the test that runs weekly or fortnightly that takes longer but runs every single test against an independent node. And if that output fails when the regular one doesn't, then that tells you you've got a dependency where you don't expect it.
Yeah, so this is more, the sort of streamlining would be more from a CI kind of perspective, right? Because currently it's, it's a bit rough.
So I have a question. You're presumably testing these nodes with small blockchains.
Very small.
Do you
currently?
Yeah. So is it just the blockchain from launch? You haven't got any network upgrades enabled?
So
I know you're mainly testing network behavior, so that would.
Yeah. So currently we are mainly basically the largest chain that we manually spin up currently is, I think, 3 blocks. Like, it's tiny.
I see. Okay. Yeah, I guess it's sufficient if you're just testing network behavior.
Yeah. The alternative would be to have a massive cache, I guess, and then just target that every now and then.
Right.
So that's also an option. How to bundle something like that is difficult, but
that's basically what we do for some syncing integration tests. We synced up to a specific network upgrade activation height, and then we snapshot that as a cloud disk. And then we literally spin up a VM, attach a copy of the disk, and run our tests and point at where it's mounted on the disk. And it's a full integration test, but it's a lot.
Yeah, we briefly considered it and then decided,
right,
maybe as a to-do.
Yeah, it definitely takes a bit of finagling, especially when we altered the timestamping behavior in the nodes to fix those timestamping bugs. Yeah. It made the logic in our RPC tests, the integration tests in Zcashd, significantly more tricky for the cached block chain tests. So there's now logic in there that if the cache is like over an hour and a half old, then we scrap it and rebuild the cache.
Yep.
Yeah, it's a bit horrible actually, but it works.
So I'm keen on that kind of testing because we've had one security relevant bug where let's see, there was if I can remember the details, there was like a privacy side channel issue because the wallet indexing or code was in line to consensus checks, which is really bad because that kind of design means there may be incidental consensus behavior bleeding across layers. So I'm really anxious about incidental consensus behavior in the networking layer. So I'm interested in testing the networking layer with full chain states loaded in Zcashd, at least sometimes, like maybe as niche testing. Just wanted to share that.
I
Yeah,
mean,
one
there's nothing
thing-
stopping it, right? It's definitely doable, but as you say, it's a bit of a pain in the ass to set up the first few times.
Yeah. One of the things you're talking about chain snapshotting, and I think Marshall's on the call, but we created some technology called testnet in a box that includes chain snapshots as well. So you can spin up your own private testnet kind of with a pre-built chain that you can just kind of start with. So depending on the type tests that you do in the future, again, kind of understanding you're testing the network mainly, but at some point, if it would be valuable to have, repeatable state testnet where you can start at a known height and test, testnet in a box might be a really good option for that.
Yeah, for example, I mean, with the worry about bleeding across layers like that, having reaching certain block heights is valuable, I think, right? Like, just if behavior changes based on that, then that's clearly a problem, right? So that would be great to test, but getting to those heights is a lot more work than just staying right at the bottom.
Right.
I mean, you can change when network upgrades activate. Well, at least you can for Zcashd in reg test mode.
Mm-hmm.
But reg test mode behaves a little bit differently than mainnet.
Mm-hmm.
Oh, that's a good question actually. What do you run in mainnet node mode only? Testnet. Okay.
Mm-hmm.
Yeah, I suppose no particular reason. I suppose started on testnet because just in case we do accidentally chat to the outside world, we don't.
Yeah, that makes sense.
Right.
I mean, the main reason for reg test mode existing is so that the Python integration tests in Zcashd are able to mine arbitrary numbers of blocks without having to deal with the proof of work difficulty adjustment. I presume you're not yet doing anything that requires mining significant numbers of blocks in your tests.
Also, Zebra doesn't have reg test, so if I understand correctly.
Yeah. So I suppose if you've got the chain separately and already done, you're just replaying it against. Actually, that's an interesting question. Do you what do you do in terms of timestamps and things? Do you have any logical plans for like manipulating time or?
No, no, not at all. We actually we just so the only sort of data seeding or that kind of thing that we do or feeding the node is we just for now actually just connect to the node and then communicate with the blocks that we do have and send them over.
Yep.
And just use the current time as that is. So we haven't sort of done any time traveling or anything like that.
Yeah.
And as I say, it's very few blocks, like literally just the first three. Although there's no reason that couldn't be higher, I suppose, apart from just literal space. Yeah, I guess maybe just quickly finish off. So currently we have this synthetic node, which is sort of which has behavior where it can just do a custom kind of handshake, or it can respond to certain events and messages. But obviously extending that to be a more and more node-like will give more and more better results. So the more nuance one can build into this thing, the better, or the more complicated tests one can write. You can sort of create a whole bunch of different nodes with different kinds of behaviors. You can have a guy that's very slow, a guy that's very fast, a guy that always responds, a guy that responds with gibberish. And sort of linked to that, we could then create custom network topologies to sort of more accurately simulate actual net behavior. It's been kind of interesting in a way because we have such a small network, in some cases even just a single node that your node can talk to, it's actually brought to light some some issues that only exhibit at small peer numbers, or when you're not established yet.
What's the largest number of nodes that you use in the test?
20,000.
Okay.
But that's for, if we're talking, that's more on the performance side of things where we're expecting you to reject most of them. So that, but on the sort of more on a communication based level, I would say, what is it? 20?
Okay.
It's usually less.
Yeah, so either side of the actual number of nodes in the network by order of magnitudes either way.
Yeah, I was when I made the performance test, I wasn't quite sure, so I started low and just sort of kept adding numbers until my computer started smoking. Yeah, then the only sort of other thing is this is a part because it's not really directly related to what we're currently busy with, but something that's sort of that can just crawl it through a net and check the health and find fault detection. I think these tools already exist for other coins.
Yeah.
In terms of network crawling, the Zebra network crate, which is just the protocol, the peer-to-peer protocol part, when we're done with all the messages, as you kind of mentioned, instead of just dropping them on the floor sometimes, could be very useful for that because you don't need a full node for that. You can just have some tool or test or whatever that just speaks the network, and it handles the negotiation and handling your address book and picking your healthy peers and stuff like that.
Yeah, in some cases though, something even lower that specifically is just speaking the protocol but has no other hand, it could be useful because it's effectively what the C++ DNS seeders are. They just copy pasted network code out of Bitcoin D, Zcashd, with a database and DNS attached to it, and so it's doing pretty much the minimal amount of networking it can in order to establish and learn about the peers. So I was just thinking this could be potentially useful for building up a Rust-based DNS seeder without needing any. If you want to do just replicate the same kind of crawl strategy that the current C++ one does without any like address book maintenance logic.
Yeah, because I mean, essentially you want some functionality and the rest is sort of just a handoff, like, okay, you can respond, but you don't say anything. Well, you don't have any information to give, so just kind of leave me alone. Yeah, that's it.
Nice.
Very good. Well, thank you. Yeah, we appreciate that. And it's been really, really great work. Strat, I don't know if you remember, but we talked to, I think it was Mark and Lucas from Equilibrium back in February. We had the session where we kind of went through some of the things that ZOMG was looking to fund, and we kind of helped match up something they were really good at. And obviously, here we are talking about the results. So it's been great work on the part of the Equilibrium team. It's been really good having you involved with the project. So yeah.
Very happy with the output.
Yeah, for sure. All right. All right. Any other topics anyone wants to discuss, or any questions about anything for Mirko or any of the teams? Anyone else? Yeah.
I mean, I'm just really impressed that you've been able to get Zebra working in that kind of environment, because it's not a use case we really designed it for. And I'm glad we managed to fix any bugs that were causing you issues with that, because yeah, I know I did some early tests back in September last year, and Zebra wouldn't work at all unless it had 2 or more peers. So yeah, just glad that you've got that working.
Nate, you were about to say something?
Oh, yeah. So I was just glancing at the Ziggurat README, and it mentions how tests can be configured, and then it mentions how to run Ziggurat, and I understand those pieces. But what I'm curious, is there another setup step that might be added to the README about installing like Zcashd and Zcashd? Or can you run it if you only have one of those nodes available?
So you can run it. I think there's a okay, but that's definitely a step that's then missing from the README. But I think our actual manual that we're working on has it. But you don't have to have both. It's an either or both kind of situation. So the Zcashd you will have to basically just install however you want, I guess. Or in our case, we're literally just turning the repo and then following the installation instructions, or the build instructions rather. So Zcashd you have to build. Zebra, because it's Rust, we can just invoke internally the Rust. Well, the actual cargo R thing will actually build it for us. So that's nice in that sense. Because we already have to have the Rust compiler.
Can you test networks that are mixtures of Zebra and Zcashd nodes?
Currently, no. Currently, we only spin up a single one of your nodes.
I see.
Suppose there's nothing stopping it. But that would fall sort of under that custom topology sort of idea, I suppose. But yeah, currently the configuration file is just a single node spin up kind of thing.
Okay. Yeah.
So the configuration for tests, let's see. So is the only, what is the purpose of the kind parameter where you name the node? I see the, the start command, it's obvious. You need to tell it how to start the target node. What else gets switched on the kind parameter? What other logic?
The two nodes for Zebra and Zcashd have different configuration files. So we need to actually generate that at runtime. So we need to know which node kind we're targeting in this case. And then certain options in them also have different namings and so on, I think.
Got it. Thank you.
But you don't actually adapt to the behavior of Zcashd or Zebra in the tests other than configuration.
Right. So the sort of going instruction is assume Zcashd does it correctly, and unless it makes no sense whatsoever, in which case, bring it up. But yeah, no, so yeah, the tests are basically have an expectation, try it out. Does the behavior that you see match that, or does it make sense even if it doesn't? And then if you have questions, ask the question. Make sure that what you're testing for is actually correct.
Cool, thank you.
Very good. All right, great work, by the way. Yeah. All right, any other questions going once?
Is there any way to spit out the encoded expectations from your test cases as they exist into proto documentation of the expected behavior of the peer-to-peer network protocol? Because we don't have any at the moment. And if we're all kind of defaulting to, well, most of the network does this right now. So if you have to choose something that is the correct thing to do, we're going to default to this unless it doesn't make sense or unless we have another reason. Is there any way to kind of automatically generate some of that to start? Because we have nothing.
Automatically, no.
I mean, I guess you could just read the tests and
yeah, so the tests should make pretty, if they don't, please let us know. Yeah, this is some, I mean, I can show a test if you want, but basically it's the test comment, or there is a test specification document, which basically lists the test that we do.
Cool.
With the,
cool. Excellent.
Do you have a link to that?
Spec.md. Let me just grab it quickly. Post it in chat, I suppose.
Yeah, if that's kept in sync with the code, then that's a very useful document.
Yeah. Yeah.
Cool.
Mhm.
So yeah, I mean, they should be up to date. These were originally, I think that this document was sort of the first deliverable we had right at the start. So that milestone 1. So since then, we've actually been writing the code and writing the tests and running them. So there's been quite a few changes in behavior that we've seen and
right, but
now
we
expect.
could
So,
use this as a starting point and then
Yeah.
check that it's consistent with the code.
Yeah.
Thank you.
if it
This is
isn't
great.
consistent, then also once again let us know. We are kind of in the sort of polishing stage. So we are these are the things that we are currently looking at, making sure they are correct. The current behavior of all of the tests as well is also documented within the actual test code. So at the top of each test, you'll see, well, for the non-trivial ones, you'll see what's currently happening, what the current results are. So for each node, for example, so Zebra passes or Zcashd fails because of this reason, which may or may not be the correct reason, but
Thank you.
yeah, and then there's a couple of performance tests. They are mainly, like some of them are, well, one of them is very simple. It's pretty much just spin up a hell of a bunch of different nodes and send as many pings as possible. See how fast you reply consistently. So the performance tests have some tables in them that may or may not be of interest. So just sort of average latencies and percentiles of them and so on.
This is great.
Very good. All right. Well, yeah, thank you again for joining us, and we really appreciate it. And well,
my pleasure.
anytime as you progress, like some of the future work you're talking about, anytime you would like to give an update, just let us know, and be happy to have you come back, or others on your team as well. So everyone's welcome. So, all right. Well, I think that pretty well covers it. So we're gonna wrap up about 6 minutes early today, but hope everyone has a good rest of the day and a good upcoming weekend. And we will catch up in Discord. So, all right. Thank you.
Thank you.
Bye.